So first of all, triangle is what your bell work was. That's 3 sides. Quadrilateral, quad, 4 sides. All right, 4 sides. All right, so everything in this particular section is about 4-sided figures. 4-sided figures. I want to talk about some definitions that are in that first paragraph because there are going to be characteristics depending on what type of quadrilateral you have, and it will say opposite sides, consecutive sides, etc. And so I want to make sure that you understand what it is saying when it gives you those terms. Opposite sides, exactly what it sounds like, but sometimes it's a little bit harder to picture. When you have a nice rectangle, opposite sides is easy to see. When you have something that's a little more skewed, it's harder to see. But opposite sides are the sides opposite of each other. Consecutive then would be the ones that go into a vertex. Okay, so if 2 sides form a vertex, those are consecutive sides. If 2 sides do not form a vertex, they are opposite sides, okay, because we only have 4 sides to deal with. Opposite angles, opposite angles. So if the 2 sides of the angles they do not have a common side, they are considered opposite. Consecutive angles will always share a side. So the angle MJK shares a side with JKL. Those are consecutive. However, the angle MJK does not share a side with the angle KLM. So those are opposite angles, all right? And so this is going to become important when you start talking about different characteristics of your quadrilaterals. All right, right below that, they have an entire list of quadrilaterals with definitions. You are going to need to know these, and you're going to need to be able to recognize them. All right, so the first one they talk about is a parallelogram. Parallelogram is a quadrilateral with 2 pairs of parallel opposite sides. You'll notice the notation here. These 2 sides are parallel, and these 2 sides are parallel. All right, this is the broadest term here that you're going to see in this set of quadrilaterals, a parallelogram. A rectangle. Well, a rectangle is a type of parallelogram. You will notice that in a rectangle, the 2 opposite sides are indeed parallel. But this is a more specific type of parallelogram. This is a parallelogram that has 4 right angles. Okay, and so we're getting a little more specific. A rectangle has 4 right angles as well as the parallel sides. We have a rhombus. A rhombus is a parallelogram that has 4 congruent sides. All right, so we have 4 congruent sides in a rhombus. You'll notice that in the rhombus, we do not have right angles necessarily, but we do have congruent sides. This little notation here tells you that we have all 4 congruent sides. All right, you'll notice that the square is the one that we usually recognize as 4 congruent sides. But the square has combined 2 characteristics here. It has combined the characteristics of the rectangle by having 4 right angles. It has combined the characteristics of the rhombus by having 4 congruent sides. It is also a parallelogram because all opposite sides are parallel. All right, so a square is technically, not that you would learn this in like kindergarten, but a square is technically a rectangle that also has 4 congruent sides. All right, so it is a rectangle that has 4 congruent sides because it meets the characteristics of a rectangle. It has opposite sides that are parallel and sides that also form right angles. The next one. Now a kite is in a group by itself, and we're about to see that with the Venn diagram, all right? A kite is a quadrilateral. You'll notice it did not start out as a parallelogram. Kites' sides are not parallel. Kites have 2 congruent sides. But specifically not opposite sides congruent. All right, so you'll notice that in a kite, we have 2 congruent sides here. The consecutive sides here are congruent. The consecutive sides over here are congruent. The opposite sides are not. All right, and then we have a trapezoid. A trapezoid specifically has only 1 pair of parallel lines. All right, and so if you have 2 pairs of parallel lines, it is not a trapezoid. Specifically, it has only 1 pair of parallel lines. This is the trapezoid you're used to seeing. This is a standard trapezoid here. You do have other trapezoids where these 2 sides are not at the same angle or even the same sides. Yeah, but they are considered trapezoids as long as they have those parallel sides. All right, I want you to look at below that. It talks about bases. All right, the sides specifically, you want to get a little more in detail with trapezoids. The sides that are parallel are called the bases. Okay, so the parallel sides are called the bases. This is going to become important when we start doing area of these particular figures. Those are the bases. And then the sides that are not parallel are called the legs. All right, so these are called the legs of the trapezoid. All right, so those are all ones that you're going to need to know and be able to recognize. You're not going to have to actually do the Venn diagram, but this helps you see and everywhere. All right. So you'll notice that the trapezoid and the kite are kind of in by itself. They are quadrilaterals. They're four-sided, but they don't have any really characteristics that go along with anybody else. They're kind of on their own. Then you have this group of parallelograms. All right. And so this is your parallelogram circle. That just means parallel opposite sides. Within that, you have more specific. You have a rhombus, which has 4 congruent sides. You have a rectangle, which has 4 right angles. And then you have the merging of those 2 characteristics in a square. All right. But all 4 of these figures would be considered parallelograms. All right. So they're all within the subtitle of parallelograms. You have just a generic parallelogram, and then you have some more specific types in here. All right. So example 1, to which of the defined subsets does each quadrilateral appear to belong? Pay attention to this word right here. There will be instructions sometimes that say you can only use the notation they have given you, okay? In this particular case, they're saying, what does it look like? All right? So sometimes it'll say only use the notation you've been given to decide what it is, and sometimes they'll want you to classify it just based on what it looks like, and that's what they're asking us here. So for this, it obviously looks like a parallelogram. So for A, it looks like this is parallel to that. It also looks like this is parallel to that. All right, so if I were just looking at this, I would call this a type of parallelogram. And then to get more specific, it also appears that these are congruent sides. So what is that? A parallelogram with 4 congruent sides. It's a rhombus, okay? It's a rhombus, 4 congruent sides. Now, it does not appear that those are right angles, so I would not assume this was a square, right? But it does appear to be at least a rhombus. All right, look at the next one. This right here, these appear to be parallel. These are obviously not parallel. And so I would say this is a trapezoid. Now, we're going to get to one more specific type of trapezoid. For this particular trapezoid, it looks like these legs are congruent, all right? And so this type of trapezoid is called an isosceles trapezoid. So think about the term isosceles triangle. In an isosceles triangle, you had 2 congruent side lengths, okay? An isosceles triangle, you had 2 congruent sides, remember? This is an isosceles trapezoid. When you have the legs congruent, the standard trapezoid that you think when you draw a trapezoid, that is an isosceles trapezoid. So you want to get a little more specific if the legs of the trapezoid are also congruent. Really, that you can tell based on the picture is that it's a parallelogram, all right? It doesn't appear that any of the sides are the same length, and it doesn't appear, or that all 4 sides are the same length, rather, and it doesn't appear that it has right angles. So you should have just chosen parallelogram as your most specific one here. Number 8. This one appears to have congruent sides here and congruent sides here. And so that only classification really for that would be a kite. For this last one, these appear to be parallel. These are obviously not congruent because they would have to be at the same angle to be congruent. So this particular one would just be a trapezoid, not an isosceles trapezoid. So specifically in this figure, this is a kite. If we know it's a kite, then we know certain things are congruent. We know that these 2 sides are congruent, and we know that these 2 sides are congruent. So if they want us to solve for the variables and we know they're congruent, we're literally going to set them equal to each other and solve. So we know that JK, the length of that one, should equal the length of JM, which means we can just write what they have given us. Add your 1 over, subtract your x over, x is going to equal 3. We can do the same thing with the other one. We know that the length of KL should equal the length of LM. So once again, we can just set those equal to each other and solve. Distribute here, subtract your y's over, subtract your 2 over, and then divide. All right. Now, if they wanted the measure, which is what they're really asking for, the measure of each side, we're not quite done. We found our x's and y's. They want to know what the measures are. Now, you don't have to plug it in all of them, right? Because if I plug in a 3 for the 5 here, for the x here, 3 plus 5 is 8. I know these are congruent, so I don't even have to plug it in. Now, you can if you want to double check it, but that one should also equal 8. If I plug in a 2 up here, I have 5 times 2 plus 2 equals 12. And again, you can plug it in here if you want. 3 times 2 plus 2 is 12 as well, but you know they should be congruent. All right, so knowing something about it is going to help. If it were a rhombus, you should know that all 4 sides are congruent as well as a square. All right, and so there are some more attributes that help us understand what we know about measurement. All right, so go ahead and try this kite. Page 253, number 26. Solve for the variable, right? And then it wants you to solve for the length. So you should have the x and y variable as well as the lengths of each side. Your 4x minus 1 should have equaled your 2x plus 3. And then the 3y minus 2 should equal the 4y minus 7. You should have gotten 2 for x, 5 for y. Both AB and AD were both 7. BC and DC were both 13. The first theorem we see is on page 250. It says the sum of the interior angle measures of any convex quadrilateral, all right, convex meaning it doesn't go in on itself, so just a standard quadrilateral, is going to be 360. And they say to prove it. We're not going to do proofs, so don't stress. We're not going to do proofs in this one. But the way they do this is they actually draw a diagonal from one vertex across to the opposite vertex. Okay, so they've drawn a diagonal from J to L. And you'll notice when you do that in any quadrilateral, you get 2 triangles, all right? 2 triangles. And so if I were to take the triangle sum theorem like we used for bell work, this triangle should have an interior sum measure of 180, and this triangle should have an interior sum measure of 180, which means that the entire quadrilateral should have an interior sum measure of 360, okay? Because if I have angle 1, angle K, and angle 3, and those are 180, and then I have angle 2, angle M, and angle 4 is 180, then what I know from triangle sum and even adjacent angle sum is that I just add them all up, all right? And so the way they did this proof is they said, well, there's 2 triangles there. And so obviously with the triangle sum theorem, it means that I'm going to have 360. So that moves us to other types of sided figures, okay? And so not just quadrilaterals, you can figure out what the sum of the interior angles is going to equal based on this concept in any quadrilateral or in any polygon, no matter what the side length. You'll notice that with a quadrilateral, we have 4 sides. We were able to create 2 triangles, which gave us 360. With a 5-sided figure, a pentagon here, we can only create 3 triangles, but 3 triangles, if they're all 180, should add up to 540. 6-sided, we create 4. That would be 720. And what you'll notice, hopefully, is a pattern here. Whatever your side length is, let's say a variable n, the number of triangles you can create is going to be 2 less than that, n minus 2. And so you take this number and multiply by 180, and you're going to get what the interior sum would be. All right? And so that's where they come up with this. The sum of the interior angle measures of any convex n-gon, meaning a polygon with whatever number of sides you have, is going to be n minus 2 times 180. So this is a formula that you're going to need to know. If you're trying to find the sum of the interior angles, you're going to take the number of sides, subtract 2, and multiply by 180. All right, number of sides, subtract 2, and multiply by 180. All right, multiply by 180. That's going to give you all of the angles added up. Now, if they just want one angle, the first thing they notice here is they say regular. A regular convex has congruent angles. So if I have a regular polygon, so let's think of a pentagon, a 5-sided, or an octagon, like a stop sign, that's a regular octagon. All the side lengths are the same. All the interior angles are the same, all right? So if I know what the sum of them are, I can just divide by how many I have, and that will tell me what one of them is. So if I were to take a triangle, I know that a triangle is 180, all right? If I know that all the angles are the same measurement, then I'm going to take 180 divided by 3, and I'm going to get 60 degrees, all right? If I were to take a quadrilateral is 360. I have 4 angles in a quadrilateral. If it is a regular quadrilateral, meaning that all the angles are congruent, I would just divide by 4. So a square is going to be a regular quadrilateral, right? It's going to have congruent sides and congruent angles. All right, and so you do that. The sum of the interior angles is just going to be how many sides, subtract 2, multiply by 180. But if you want to know what one of the interior angles measures for a regular one, you're going to divide that total by how many angles you should have, which is back to the number of sides. All right, let's look at an example. A gazebo. The footprint of this gazebo is a regular octagon. This is example 4 on page 251. Find the sum of the measure of the interior angles and find the measure of each interior angle. All right, so I have an octagon. The sum of the interior angles. So to find the sum, I'm going to take the number of sides, subtract 2, and multiply by 180. In this case, I have an octagon. How many sides do I have? 8, all right? So I have 8 minus 2 times 180, all right? Which means I'm going to have 6 times 180, which should give me 1,080 degrees, all right? That's if I took every angle inside and added it up, I would get 1,080. All right, then it says, find the measure of each interior angle. So they want to know what every single angle, what that individual angle measurement is. So I'm going to take, if I want the measure of one interior angle, all right, I'm going to take that sum, 180, and I'm going to divide by 8. So one angle should equal 135, all right? And so if they're building a gazebo, by the way, when they're constructing this is how they're going to know they have a good build for this. Every angle measure from corner to corner should be 135 degrees. If it's not, they've done something wrong and their gazebo is going to be offset, all right? For heptagon, you should have gotten 900. 900, all right? How many sides is a heptagon? That's important. 7, all right? 7, so 7 minus 2 is 5. 5 times 180, you should have gotten 900, all right? A pentagon. How many sides is a pentagon? 5. So the first thing you would do is 5 minus 2 times 180, and then you're going to divide that by 5. So you should have gotten 108 here for the individual interior angle measure, all right? All right, one more thing, exterior. So this we're talking about the inside angles. Exterior angles, if you were to take each side and draw a line continuing out from it. And so you'll notice here that we have this line and it goes out and it creates an angle here, which is 75, all right? And then we have the next one here, which continues out and forms this angle, the 113. Continue this side out with the other side and you get the 107 degrees. And then if you were to take this last one and continue going with the side here, you're going to get 65. So those are the exterior angles, exterior angle. So that was a quadrilateral. This is a triangle, all right? So you'll notice it doesn't give you the same. How do I know it's not the same? Well, if this were the same angles, those should add up to 180, right? but they don't. So you'll see this exterior angle is 155. This exterior angle is 135. That exterior angle is 71. Obviously not 180.
I was talking just about.
All right, look at the pentagon. So the pentagon, again, you'll see this. Now what you'll notice is the more sides you have, the more it starts to look like a spiral. It starts to look like a spiral because it actually is forming basically a circle. Because if you add up all of these and all of these, you're going to get 360. In fact, it doesn't matter how many sides you have, your exterior angles will always add up to 360. Always. All right? And so if I were to put 10 up there, you would start to see the spiral even more. And then 20, that spiral would get tighter. And you would start to see that you're forming the spiral of angles as you add sides. And that's because your angles always add up to 360 when they're on the outside. It does not matter how many you have. All right? It's always going to add up to 360. All right, so no matter what it is, if then you wanted to find out what one, if it was a regular one and you wanted to find out what one of those equals, all you have to do is take the 360 and divide by the number of sides. And then you're going to get what one exterior angle equals. All right, so the sum of the measures of the exterior angles is always 360. If you wanted to know one exterior angle, you could just divide that by the number of sides. Always divide 360 by the number of sides.